Video lesson 12.1, derivative rules, specifically product rules. So when we're solving derivatives, and finding derivatives, I should say, there are multiple ways that we can go about it depending on the information. So the most common one and the most useful is the power rule. Again, but that's specifically works when we have individual terms. So when we have things like two products of two terms, we can shortcut the process and use the product rule. So in this case, the derivative of the product is of the two function would be like the first derivative times the second part plus the second derivative times the derivative of the first. So from here, so that's the rule that goes along with this. So this is your product rule. And I wanted to show you it in both ways, what we could do without the product rule and then how the product rule can help us. So if I just distributed this out in this first example, we could just say a regular FOIL process and do like so. Yeah, you'd get 8x to the 8th plus 2x to the 4th plus 8x to the 5th plus 2x, right? So we could do that and then produce the derivative by simply saying, okay, that's 64x to the 7th plus 8x to the 3rd plus 40x to the 4th plus 2. And I would just rearrange this to make it nicer in descending order. And it would look something like this. And that would be it. And it's not terrible, but what happens when these two terms are bigger? Like maybe one's a binomial, one's a trinomial, or you got two trinomials, or you got a trinomial and a 4-term polynomial, or something like that. That's going to get way more involved, more of a process, and I don't really want to do that all of that time. And there's also sometimes you can have these things being raised to a power with itself. So again, not going to be as functional in the grand scheme of it. So the other option is to use this actual rule. So we're going to find this by simply saying the derivative is, we're going to say the first term, which is, I'm going to say here we'll call this one, I'll put that one in red, put this one in green, right? So first term, 2x to the 3rd plus 2. Times the derivative of the second. So this part here, I would use the power rule. That's going to be 20x to the 4th plus 1. And then I'm going to add this second term, 4x to the 5th plus 1x. And we're going to multiply that by the derivative of the first, which is 6x squared. Plus 0, right? I'll do plus 0. So that would be the idea. And all I'd have to do is simplify this. Now, if I simplify this completely, it's going to look like this, right? But the nice part about this is a lot of times we don't have to, right? We can just kind of leave it here, in here. Now, if it's two binomials like it is right now, it's not terrible. We could just leave that here. And like this, or again, if I actually FOIL this out and distribute it there and combine them, I'm going to get this over here. But again, I don't have to do that. I could just kind of leave it in this format then. But again, if you needed to, you could. But that's the process. That's the derivative itself. And that's why it's a little bit nicer sometimes and faster, because I don't have to go through a lot of simplifying when doing this. All right, let's try one more example just so you get the general sense of how it works. And then you can use the practice problems for better understanding. All right, so let's do this one. All right, so we'll say here, I'll call this the pink one, and we'll call this the blue one, right? So f prime of x is going to equal first term, so copy the first, times the derivative of the second. Right? Plus, copy the second, times the derivative of first. All right. Honestly, that could have just combined like terms there. Made my life a little bit easier, but you get the idea. So now I can say, well, that's just 7x squared times negative 15x squared minus 2. Plus, again, same thing here. I can just combine that and say that's 14x times negative 5x to the third minus 2x. And honestly, because it's single terms and monomials in the front, I would personally distribute this just to make it a tad bit simpler. But you could technically leave it in that format if you wanted to. But, for argument's sake, for argument's sake, let's just leave it the way it is. But again, I could distribute this out and get it into one big expression. But again, it's not required. But because of the monomial portion of it, it's not terrible to do overall. But again, that's the idea. That's the process. All right. So take the opportunity, use the rule. It's all about memorizing this format. All right. Again, I like to refer to it as first times the derivative of second plus the second times the derivative of the first. I just think it's easier to remember rather than saying f of x, g of x, and g prime and all that kind of stuff. All right. So take that opportunity to make sure you go over the video, make sure you have good notes, and use the practice problems for better understanding.